Sometimes it is very much required to transform a delta connection in an electric network to star for simplifying it. For delta to star transformation, we will first consider 3 points A, B and C on a network where a delta is connected as shown. Here, resistor R1 is connected across points A and C, resistor R3 is connected across points C and B, and resistor R2 is connected across points B and A. Now, suppose an equivalent star is connected in place of the delta, and we have to calculate the resistance of each arm of the star in terms of each resistance of that delta. Let arm of resistance Ra of the equivalent star is connected with point A, arm of resistance Rb of the equivalent star is connected with point B, and arm of resistance Rc is connected with point C. Now think about the resistance value of the delta across points B and C. And as you see from the diagram, there are two parallel resistive paths across B and C. One path is through resistor R3 and another path is through series combination of R2 and R1. Hence, the equivalent resistance between these points will be parallel combination of R3 and R2 plus R1, and this is equal to R3 into R2 plus R1 divided by R1 plus R2 plus R3. Now think about the resistance value of the star across same points B and C. As you see from the diagram, there are two resistors Rb and Rc across the points B and C. Hence, the equivalent resistance between these points will be series combination of Rb and Rc, and this is equal to Rb plus Rc. Here Ra will not come into our calculation as it is just open circuited. Since the two systems are identical, resistances measured between points B and C in both of the systems must be equal. So, Rb plus Rc is equal to R3 into R2 plus R1 divided by R1 plus R2 plus R3, and say this is equation 1. Similarly, if we think about the equivalent resistance of delta and star respectively in between points C and A, we can prove that Rc plus Ra is equal to R1 into R3 plus R2 divided by R1 plus R2 plus R3, and say this is equation 2. When we think about points A and B in the diagram, we can similarly prove that Ra plus Rb is equal to R2 into R1 plus R3 divided by R1 plus R2 plus R3, and say this is equation 3. Now if we add equations 1, 2 and 3, we shall get 2 into Ra plus Rb plus Rc is equal to 2 into R1 into R3 plus R2 into R3 plus R1 into R2 divided by R1 plus R2 plus R3, or Ra plus Rb plus Rc is equal to R1 into R3 plus R2 into R3 plus R1 into R2 divided by R1 plus R2 plus R3, and say this is equation 4. Now if we subtract equations 1, 2 and 3 from equation 4, we will have respectively Ra equals R1 into R2 divided by R1 plus R2 plus R3, Rb equals R2 into R3 divided by R1 plus R2 plus R3, and Rc equals R3 into R1 divided by R1 plus R2 plus R3. This is resistance of each arm of the star in terms of each resistance of that delta. Thank you.